Hello again, this is example 2 on permutations and combinations. The directive committee of Carib Christian School has 5 members. How many ways are there to choose 3 separate office holders? Director, assistant director, and secretary. And how many ways are there to choose a committee of 3 people? So I have 2 questions here, and you're going to see that we're going to solve these differently because one of them is a combination and one of them is not. So let's see letter A. Letter A says that from these 5 members in the directive committee, how many ways are there to choose 3 people from these 5? And those 3 people are going to hold separate offices. That means one of the persons I picked is going to be the director, the other one is going to be the assistant director, and the other one is the secretary. Okay? So what do you think? Is this a permutation or is it a combination? You need to determine that first in order to solve this problem. Okay, let's go off to the side here and write some things. For letter A, I have 5 members. I'm going to draw little boxes just to represent each member. I have 5 members and I'm going to identify the 5 members with a letter, with their first initial of their first name, okay? So let's say this is Tom, and let's say this is Laura. Tom, Laura. And let's say this is Mike, Sandra, and let's say we have a Peter. Okay, those are my 5 members in the directive committee. Now for letter A, it says how many ways are there for me to choose 3 separate office holders? That means I'm going to choose 3 people randomly. Let's say I choose Tom. And then I choose Mike. And I choose Sandra. I randomly chose these 3 people. Now, the first person I choose from that group of 5, that person is going to be the director. The second person I choose, that's going to be the assistant director. And the third person I choose, that's going to be the secretary. Okay? So that's one way of choosing 3 people from a group of 5. Let's say now I choose Sandra first, and second I chose Mike, and third I chose Tom. Now that first person I chose this time, that one's going to be the director. This is the assistant director, and this one's the secretary. So notice that even though I chose the same 3 people both times, they will hold different offices in these 2 arrangements. So again, if I'm picking people out of a group and I say the first person I pick is going to be the director, the second one is going to be the assistant director, and the third one is the secretary, and I choose these 3 people in this order, then this is the office they're going to hold. Now, let's say again randomly I choose, let's say I have their names in a bag. I choose again from the bag, and out comes Sandra as my first person to come out of the bag. Now she's the director. And then comes out Mike. Now he's the assistant director. He kept his same office, right? And now Tom is the secretary. Now notice these 2 ways of picking 3 people are actually different from each other because not the same people hold the same office in both cases. And I can keep going and I can make another one. I can say, well, out of the bag came out Mike first, and then came out Tom, and then Sandra. Well, now Mike's the director, and Tom is the assistant director, and Sandra is the secretary. So this is very different than this arrangement and then that arrangement, even though I have the same three people. And this will happen if I choose, for example, Peter, Laura, and Mike. I will have instances where they will come up again and again and again, but with different offices. Okay? So since this arrangement is different than this one and different than this one, that means they all count. They all count. So that means this becomes a permutation. Letter A is a permutation problem. And we write 5, P3. We're choosing 3 people at a time from a group of 5. And that's 5 factorial over that. And you can do that in your calculator. This becomes 5 factorial over 2 factorial, which is 5 times 4 times 3. And that's 60 different ways in which you can choose 3 people out of 5 to hold these offices. For letter B, how many ways are there to choose a committee of 3 people? A committee of 3 people, they're not holding any office. So what this means is you're going to make a group of 3 people out of the 5 people that I just named here. So let's say I choose Laura, and I choose Mike, and I chose Peter. And I form a committee with these 3 people. And then when I go back to choose another committee of 3 people, I come up with Mike, Peter, and Laura. This committee is exactly the same as this committee. So I'm not going to count it as 2 ways. This is the same group of people. Even though they were chosen differently in a different order, it's still the same committee because the 3 people are the same people. So in letter B, this would be a combination. And remember, combinations will divide out the non-distinguishable permutations. So this would be C53, which is 5 factorial over 5 minus 3 factorial times 3 factorial. 3 factorial are the non-distinguishable permutations. So this is 5 factorial over 2 factorial times 3 factorial, which is 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. And then you can cancel out 3 times 2 times 1 with 3 times 2 times 1, and 20 over 2 equals 10. So notice when you do combinations, you get a smaller number than when you have permutations, because permutations will count all the events as different events, and combinations will take all the events that are repeated, like this one here, and we will divide them out. So I hope this makes it clear. I'll see you in the next video for example 3.